All right. I think we got it going here. Let's see. All right. I think we're live. Okay. So, yeah, welcome back, everybody. New week. Happy Monday. So this is the second workshop now in this series that I'm doing on, just going through all of the different AWS workshops. And I thought this one was a good next step to build off of the previous series or live stream where we learned, like the fundamentals of Python on AWS. So using like the Amazon Translate service and whatnot, and then sort of taking that a step further now and starting to build like infrastructure as code with Python using the AWS CDK, the Cloud Development Kit. If anyone knows me out there, I'm a huge fan of the CDK. After many years of writing, well, not many years, but as many as like a seasoned architect can be, but wrote a lot of just raw cloud formation over the last few years, and I remember writing a lot in JSON initially, and now YAML was like the next easier thing to do, I guess, and but still, it's very low level, right? Like it's very declarative in that you have to be very granular with how you uh, write your infrastructure as code. And so the CDK is just like a godsend almost. Like it's amazing because you can write these higher level abstractions or constructs to sort of like bundle like best practices together, and being able to deploy a lot of different resources within just a few lines of Python. It's pretty amazing. So pretty excited to go through this workshop and sort of like go back through it after I've, used the CDK now. And yeah, so let's go ahead and just get started. So this is, like I said, this is the CDK workshop. This is specifically the Python portion of it, but you can see here that they also have a TypeScript workshop, .NET, and Java as well. So, pick your poison, whatever you think you might be interested in. But gonna stick to Python for this one and go through it. So over here, I already have a Cloud9 instance up and running, and then I also have my Notion notes here, just in case something comes up that seems interesting that I should take notes on, and make a note of for later and share that in the description of the videos later on. So, all right. So creating your first CDK project. In this chapter, we'll use CDK init to create a new CDK Python project. You also learn to use the CDK toolkit to synthesize an AWS CloudFormation template for the starter app and how to deploy your app into your account. All right. So it looks like, we just start with creating a project directory. And then we can initialize the app. font might be a little too big, maybe. That'll work. Anyways, yeah. So once you initialize the CDK app, gives you this nice little like next steps kind of to activate the virtual environment. Looks like some uh, CDK commands. That's new, I think. Oh yeah, what's interesting is I didn't even install the CDK. Like it came pre-installed on this Cloud9 instance, which obviously tells you, like that's where Amazon is, I mean, it's coming with the Cloud9 instance, so they obviously are building it into more services and whatnot. So pretty interesting. Okay, so yep, that's the output that we got. Yeah, I guess if you haven't already installed the CDK, uh, the command, you have to have node npm installed. So npm install AWS CDK like that. Or is it underscore CDK? Let's just Google that real quick. Hmm. Did I? Oh, already starting out with the typos. Classic. Hmm. Anyways, I'm not. I don't. I don't think I'm gonna go down that rabbit hole just yet. So, all right, back to the workshop here. Since we've already initialized the app, let's go next. So we can just activate the virtual environment, which comes with the when you initialize the app. So, and then next we'll pip install the requirements. I wish this wouldn't show up in. Oh, okay. Here we go. Just 1 second. Okay, there we go. All right, back to it. So it looks like they use VS Code, which is totally fine. You can use VS Code in this workshop as well. Like I said, I'm using the Cloud9 IDE. So let's see. I think it's telling us to look at the project structure, which can be found over here. The .env is, like I said, where the virtual environment information is located. We have our CDK workshop directory here. Seems a little big. All right. And we have like a tests folder here with some predefined tests and stuff, which is cool. And the reason why it comes with the test, I believe, is because what is going on here? Let me just we when we initialized the CDK app, we used the sample app flag so that it came with a lot of this boilerplate, including the tests as well. So, okay, so contains all tests, app.py, the main for the sample application, CDK JSON. Cool, pretty standard. Okay, so app.py is the app's entry point. So if we come down here and open up app.py, move this over a little bit. Can everyone see that? You can see it sort of creates this by default, similar to what we got in the workshop here. This code loads and instantiates an instance of the CDK workshop stack. Okay. Right. Yeah. So if we go back into CDK workshop underscore stack, this is where the meat of the application is. So you can see it's like bringing in these different packages for IAM, SQS, SNS subscriptions. As you can see, our app was created with 2 instances of sample CDK stack. This stack includes an SQS queue, SNS topic, subscribes the queue to receive any messages published to the topic. Yeah. Yeah, pretty simple sample application here, but I mean, this is probably the bread and butter of it, right? You get these methods that you can call to just connect 2 different services together, and then there's no like IAM permissions that we're specifying here because it's all by default within these helper functions or whatever. Okay, so synthesize a template from your app. AWS CDK apps are effectively only a definition of your infrastructure using code. When CDK apps are executed, they produce or synthesize an AWS CloudFormation template for each stack defined in your application. To synthesize a CDK app, use the CDK synth command. Let's check out the template synthesized from the sample app. Because our app includes 2 stacks, we need to tell the CDK synth command which stack we want to synthesize. So yeah, CDKLS. So we get the CDK workshop. I'm not sure this is not supposed to be there because when you do CDKLS, you're only getting one stack anyway. So not entirely sure why it says that there. But so if we run CDK synth, we'll see within the terminal here that it's like synthesizing, how many lines is this? 24 lines of our CDK code into a CloudFormation template. So if you've worked with CloudFormation templates in the past, this will look very familiar. Got the resource types and whatnot, but it's automatically added. Okay, cool. Moving along. Okay, bootstrapping an environment. The first time you deploy a CDK app into your environment, you'll need to install a bootstrap stack. This stack includes resources that are needed for the toolkit's operations. For example, the stack includes an S3 bucket that is used to store templates and assets during the deployment process. Okay. So I'm pretty sure I've already ran this within this account slash region, but let's just see what it does anyways. Yeah, I didn't think so. Okay, so now we can just run CDK. So here again, it's specifying the. I don't know why it keeps reloading like that, but okay. So yeah, like I said, I don't know why it's specifying the stack name here, but because we only have one stack, so I think you can just type in like CDK deploy. If we had two different stacks, I think you would have said, hey, you have to pick one of the stacks to deploy. But since we only have one, it doesn't matter. So yeah, now we get this cool like IAM statement changes that give us a look at the IAM specific changes that are going in. So let's go ahead and deploy that. Yeah, so it says here like this is warning. This is warning you that deploying the app entails some risk, since we need to allow the topic to send messages to the queue. We're also creating an IAM user and granting access to the buckets. Right. Yeah, so we could go to the CloudFormation console and see our templates. But yeah, pretty cool. I mean, it's a pretty common use case. But I kind of agree with this, right? Like I am ready for some actual coding. So so yeah, let's go ahead and continue on here. Hello CDK. Oh, I forgot. Okay. So I have my banners still, right? For my stream production awesomeness. So let me just hello CDK. Yeah, that just looks good. Okay, so we are on hello CDK. Let me just hide that now. In this chapter, we'll finally write some CDK code instead of using the sample app. So instead of using the sample app, we'll add a Lambda function with an API gateway endpoint in front of it. Users will be able to hit any URL in the endpoint, and then they'll receive a heartwarming greeting from your function. Delete the sample code from your stack. So the project created by the CDK init sample app includes an SQSQ, right. So open our stack.py and clean it up. Eventually it should look like this. So we'll just get rid of, is that too small now or? Hope not. All right, so let's just get rid of this here. I'm gonna see if I can lower the terminal font here. It's a little bit big, I think. Can never remember where it's at either. So this is great. Is it not right here? All right. Well, anyways. Okay. Sorry. I guess we'll just keep going with the large font. I guess it doesn't hurt, right? It's good enough. So, all right. So now that we've deleted those like previous resources, we can run a CDK diff. And this will show us the difference between what we previously had and what we're trying to get rid of these resources. So sees that we want to delete those, and then to actually proceed with deleting them, we just do CDK deploy. Now you should see the resources being deleted. All right, gonna move on to the next spot here. Okay, so Lambda handler code. We'll start with the AWS Lambda handler code. We'll create a directory called Lambda. So I'll do that now while that's still running. So in the root of, right in here. So we need a new folder called Lambda. And then a new file called hello.py. And then we can just copy and paste this into our Lambda. So yeah, like I said at the beginning, it's just going to return a message back to us. So let me just save that. So the function's output also includes the HTTP status code and HTTP headers. These are also used by API Gateway to form the HTTP response to the user. This Lambda is provided in Python. For more information, okay. Install the AWS Lambda construct library. So the AWS CDK is shipped with an extensive library of constructs called the AWS construct library. The construct library is divided into modules, one for each of the AWS services. For example, if you want to define an AWS Lambda function, you'll need to use the AWS Lambda construct library. So we didn't really know it before, but we had already, go to the Python here. We had already used, SQSQ, right? So that was already like in the setup.py here, I believe, right? Yeah. So when we initialized the CDK project, it had this already in the setup.py. And then when we did the pip install the requirements.txt, it brought in all of these modules for us automatically. So kind of have to do the same exact thing, except this time with the Lambda module. So again, yeah, we'll just do another pip install this time with Lambda. Okay. A few words about copying and pasting in this workshop. We highly recommend to type CDK code instead of typing or copying and pasting. This way you'll be able to fully experience what it's like to use the CDK. Especially cool to see your IDE help you with autocomplete, inline documentation, and type safety. Which is true, right? That's like one of the other major benefits of this is like not having to go back and forth between the like CloudFormation docs, which is probably half of my career so far as a cloud architect has been in those docs. Okay, so now we can get rid of this here, and I'm just gonna so we have to put this underscore here too. I don't know if it mentions that. Oh yeah, here it goes. I've fallen for this before too. So we're importing the AWS Lambda module as underscore Lambda because because Lambda is a built-in identifier in Python. So cool. All right, so now we need to define our resources. So my lambda equals lambda dot function. It's kind of interesting. I'm not seeing the normal. We're not getting our auto completions, so not sure why. All right, so we're using the Python 3.7 runtime for our Lambda function. Handler code is located in the path is relative to where they execute CDK from. The name of the handler function is hello.handler. Hello is the name of the file. Handler is the name of the function. Yeah. So in this code parameter here, right? We're using like this asset method here to grab the local directory, which is Lambda here. And then within the Lambda directory, we have the handler, which is the name of the file, which is hello. And then handler is the name of the function within this hello right here. So. Okay, so a word about constructs and constructors. So as you can see, the class constructors of both CDK workshop stack and Lambda function. Many other classes in the CDK have the signature scope, ID, and quargs. This is because all of these classes are constructs. Constructs are the building blocks of CDK apps. They represent abstract cloud components, which can be composed together into higher level abstractions via scopes. Scopes can include constructs, which in turn can include other constructs, etc. Constructs are always created in the scope of another construct and must always have an identifier which must be unique within the scope it's created. Therefore, construct initializers, constructors, will always have the following signature: scope, which we see here. Okay. Scope, the first argument is always the scope in which the first construct is created. In almost all cases, you'll be defining constructs within the scope of current construct, which means you'll usually just want to pass self when we create resources. Yeah. ID, the second argument, is the local identity of the construct. It's an ID that it has to be unique amongst the constructs within the same scope. The CDK uses this identity to calculate the CloudFormation logical ID for each resource is defined within the scope. So it's not the same as logical ID, but it's used to um, calculate the CloudFormation logical ID. Okay. Quargs, the last, sometimes optional arguments uh, is always a set of initialization arguments. Those are specific to each construct. For example, Lambda function constructs accept arguments like runtime, code, and handler. You can explore the various options using your IDE's autocomplete or the online documentation. Yeah, I don't know how I would try to figure out like why the code completion wasn't working. I'm not even sure. All right. So let's run the CDK diff again. We can see that it's going to create two resources here. And I am rolling a Lambda function, which is great. So we'll just deploy our Lambda function now. And then it looks like we can go into the Lambda console. It's not done yet. All right, so let's see. And I have a lot of Lambda functions in here. Okay, I think I found it. So here's our like hello handler function. So now we can test this guy. So we can, it looks like we can select a different event template. Let's look for API gateway. Say test. And then we can hit create. And then click test. And we can expand the details. Nice. Looks like it worked correctly. All right. So it looks like now we're going to add an API gateway to the front of our function. So API gateway will expose a public HTTP endpoint that anyone on the internet can hit with a HTTP client, such as curl or a web browser. We will use Lambda proxy integration mounted to the root of the API. This means that any request to any URL path will be proxied directly to our Lambda function, and the response from the function will be returned back to the user. So we need to add API gateway construct library. So if I come back over here, oops. Oh, did it kick me out? Looks like I got kicked out. I think it has something to do with, now that I'm kind of thinking about it here, like the auto completion. Maybe it's because we don't have them in our setup.py. Like, let's just try this real quick. So AWS CDK dot AWS API gateway. What also what see what happens when we do that, and then we say like pip install requirements txt. Oh, duh. Okay. So I wonder if that worked. So if we come back over here, and now we add AWS API gateway as API GW. And then below our Lambda function, we say API GW that Lambda. Yeah, still not, so weird. Like we should be getting like code completion here but it's not working for some reason. I don't know why. Self. That's it. That's how easy it is to add the Lambda the Lambda proxy integration to the API gateway. Pretty easy. CDK diff. So yeah, I mean, I think this is pretty cool because we barely just added these three, four, four lines, right? And now you can see all these like resources that are going to be created, and IAM roles and permissions that are built in. Like you don't have to get to that low level of determining the least privilege. It's already like built in for you, and like that's just saves so much time, like time and effort, to do something as simple as providing least privilege from one service to another. So just another reason to really love CDK. So if we write CDK deploy, that's gonna go out and deploy for us. Should provide an output for the endpoint of the API gateway. Also, if there's anyone out there that knows how to like play music through StreamYard, let me know, because I don't really like wearing the headphones, but I like to listen to music while I'm kind of going through this stuff. So, all right, so that looks like it finished. Finished and provided this output for the API gateway. So testing your app, let's try to hit the endpoint with curl. All right. I don't know if curl is installed on here, but oops. That looks a little bit better, huh? Okay, so curl. Nice. You can also use a web browser. So plugging in a new web browser up here. That works too. Very cool. If you received a 500 error from API Gateway, it's likely one of two issues. The response for your function returned is not what API Gateway expects. Go back and make sure your handler returns a response that includes a status code, body, and header fields. Or number two, your function failed for some reason. To debug this, you can quickly jump into this section to learn how to view Lambda logs. Good luck in the next chapter. We'll write our own reusable constructs. Awesome. All right. So it's been about an hour. Um, I think I'm going to call it here and then pick up tomorrow on the last two sections. So we were able to build a new project with one of the sample apps using the CDK and init. And then we removed those resources and built uh, an API gateway with a Lambda function. And we are able to see like, you know, this, actually, let's do a CDK synth out to a template.yaml. Curious to see if this works. Yeah, so you can actually synthesize like your CDK into a YAML file. Let's take a look at that right here. So like it's just kind of gives you an idea of like the difference between writing, 22 lines of Python, which is mostly white space, right? Like the the real, there's about 10 lines or whatever, like not even, it's just to create a full API gateway with Lambda integration. No, all the IAM is wrapped up in these within these constructs. And if you were to try to write that into CloudFormation with just straight like raw CloudFormation with YAML, it looks like, it sort of looks like this, right? Like you have to create a role for your Lambda. Here's like the actual function itself. Here's the API gateway, the role for CloudWatch. Yeah, I mean, so on and so forth. Just like everything that you would need to write in CloudFormation, it's all sort of abstracted for you, and it ends up being, with metadata in there, right? So it's not all, but still, the point is here's 283 lines of YAML CloudFormation code that we were able to really write in roughly 10 lines or so of CDK code. So that really shows the power of it, right? And how cool this, this can really be with creating these constructs and whatnot. So yeah, I mean, I'll leave it at that for today, and then probably tomorrow, round 4, I'll pick it back up and continue with writing constructs and using construct libraries here. Cool. All right. Well, yeah, I'll see you guys next time. Thanks.